think it's recording. Okay. All right, so let's move on to some geometry stuff. And this might help you to understand some of the questions you may have been stuck on the pretest. So array. Array is anything that has an endpoint and passes through another point forever in that direction. So let's look at IC, right? So where's I start? Clearly I starts over here and C's over here. You see the arrow going forever towards C's direction? So it has to have an endpoint and just one endpoint. That's it. So the endpoint is I. How would you describe array? So the way I would describe it, and you could paraphrase. I'm gonna type this as a text box because my handwriting's not the greatest. But I would say array has an endpoint and heads towards another point. Let me think about this. Array has an endpoint. Yeah, it heads towards another point. Yeah, yeah, I think it's fair. So like a sun ray or I don't know, light rays, laser rays, beam rays, whatever, right? So it has an endpoint and passes and heads towards another point. So can I name other rays? Like for example, what if I said DC? I could start at D. I didn't have to start at I. Could start at D and go towards C. I could say GC, right? Um, Let me ask this question, and this is going to answer a question later on. Um, Ray IC, and by the way, always write like this: an arrow, right? You have an endpoint and you have an arrow. And very important, order matters. We got to be incredibly particular about and very OCD with stuff like this. Math. Now I'm like, I mean, I'll show you my folders, right? Like, let's see if I show you like my something I do for like SAT preparation. But to a fault, I'm just like crazy about my sense of organization. Yeah, first of all, I see those folds like this is like Princeton Review, and then like this is SAT math. Then I've broken down by category and difficulty and topic. That's just my nature. Not saying you got to be that way, but ultimately you have to have some sort of obsession with like keeping things in order in math. So that's something we have to be very mindful about. So I put I first, put C second for that reason, because I'm starting I and going towards C. Now, what if I wrote ID? Let me ask this question. Are those the same thing? Why or why not? Did it both start the same place? Did they both go in the same direction? They're the same. Yeah, these are the same actually. Because here's the thing. ID is this, right? And is it going to stop when it hits D? No, it just keeps going forever. What about IC? Keeps going forever. They're actually the same thing because they start at the same place and they go in the same direction. So array as an endpoint heads towards another point. So start at the same place, same starting point. Told you my handwriting sucks. Same starting point, and they head in the same direction. Right? So array covers all the points starting from I and going in the direction of C and beyond. Highlight it, which I just did. The array includes points that are not labeled on the diagram. Add a few points on the array and label them. Yeah, sure, like G and D, right? But how many points make up IC? Truly, there are infinite points. So this is another topic we need to discuss. Okay, let's look at between G and D. How many dots can I write in between G and D? I can do as many as I want, right? I mean, obviously, my marker here, right, is not so fine. Like, I mean, sure, 1, 2, 3, 4, 5, 6, 7, 8, 9. But I can get really, I don't know, it's not super tiny, but I can get really tiny, right? there's infinite points between any 2 points on a segment. So for array, of course it'd be infinite. Of course it'd be. Right. Um, okay, so far all makes sense. We're all good. Okay. So now let's look at the next question. What do you guys think about AG and GA? So Ray AG and Ray GA, even though they have the same letters, but they're reversed, are those identical rays? Yes or no? No, so you're shaking your head no, Jake. Why is that? Correct. Yes, 100%. And they start differently as well. They're going opposite ways. Correct. Good. Yeah, so AG will go red, and I'll go say dark blue for GA. The overlap, of course, right? Fine, whatever. But the answer is no. And that's because different starting points. I swear I need to buy a stylus. I'm like so lazy. Different starting points and different directions. Now, GI, um, sure. Does it exist? Yeah. I mean, even though there's an endpoint there, you just force the issue. Sure, why not? Yeah, sure. Of course it exists. So a lot of this might seem very rudimentary, so I apologize. Actually, I'll be honest, like the first stage geometry is not my favorite. Um, and I kind of lied. I have taught a geometry course. I did teach a full year of geometry at another school a few years ago. So yes, I have taught geometry, but yeah, the first day is not my favorite. It's just a lot of just terminology, but it gets more engaging. Let me close the door so we're not distracted. Okay. I want to kind of get to the end of the page because it is 9:50, so I want to be mindful of time. Because we're just gonna keep working these notes when we get back. Let's finish off the page and we'll take a break. I think that'll be good. So let's look at lines and line segment. That's kind of a good place to take a break. Um, okay, so let's take a look at HA and HB. All right. And actually, I'm gonna need a copy of the notes in front of me because now I'm hiding the diagram. Okay, HA and HB. How would you describe those? Those are also different. I don't mind that. That's the building is trapping us. That's AI taking over the world. I'm just kidding. No, it's a keep the temperature cool because it blocks out the sun. But it's kind of cool. It does it automatically. I think it's AI generated. I don't know. Also different rays, but same starting points. Just different direction. Right. Now line, no endpoints. Goes on forever. No endpoints. Forever in both directions. Where rays forever in one direction, a line's forever in two directions. That's why I have two arrows. The line includes points that are not labeled in the diagram. Add a few points on the line, label them. How many points make up AB? Obviously, it's infinite. Don't worry about the labeling part. Just a bunch of dots you draw. Then finally, a line segment. Um, it's the opposite of a line. Does not go forever in both directions. Has two endpoints. So if you're to label it, actually, let me do label it right now. Hold on, before I move this screen. Any questions? You guys got all that stuff? We're cool. All right. Yeah. So line AB. So line AB was like this, right? But segment AB is like this. Okay, that is terrible. It's not a straight line, but whatever. Lines are straight. It's just not straight. But yeah, there you go. 2 endpoints, right? It's still infinite amount of points in between them. Just doesn't go on forever. The segment includes points are labeled on diagram. Obviously, we don't have to state those, but still infinite amount of points. And does not go forever in either direction. So, okay. We're good? Yeah. All right. So let's take a break. It's 9:53-ish. So let's say 10:03 has come back. We'll plow through the notes. Grab a snack. Let me open up for you guys. Let me pause here. Yeah, feel free to walk around with fresh air.
Katie, I have a quick question.
Yeah.
When you're writing the line segments, is there like a certain way that you have to like put one first?
No, oh, that doesn't matter. No. You can do whatever you want. Yeah, that won't matter at all. Are there other people from girls' middle school coming to?
Tiffany and then Anya.
Okay,
I think there's one more, but I think there's one more, but I can't remember. Oh, Queenie.
got it.
Did you know that also my sister went here as well?
Oh, who's your sister?
Tiffany Sanchez.
Yeah, that sounds familiar. But do you know a woman by the name of Meg Bannock? Does that name ring a bell? There's some woman I know. She works with girls from girls' middle school, and I've been doing some tutoring with her. But I was wondering if you. No. Okay, no worries, no worries. I was curious. Hold on. Yeah, I'm trying to think. Let me look at my records. See if that does sound awfully. What? How old's your sister?
It's now 22.
I think I taught her during the pandemic. Yeah, did she graduate in 2021?
Yeah.
Yeah. So yeah, right here. Yeah, I taught her AP Calculus. I didn't get to see her in person.
Oh.
I got to teach her fully on Zoom, which really sucks. Yeah. Yeah, because she was probably in my let's see. Yeah, this was yeah, we had to meet outside. Yeah. Good morning, everyone. Remember, we have slight new place for our in-person classes today and tomorrow. This is March. We're still in Morey Field, which is the baseball field, but this time we'll be in the. Yeah, yeah, that's crazy. Yeah, and it was that was a crappy year. Yeah.
That's
Yeah, what we did was during the pandemic, we closed in the entire fall. We were not open. Then when as you remember, like when people were getting vaccinated, like we were still in the purple category, purple tier. And we stayed closed for another 2 more months. And then we decided to do this stupid, silly thing like, oh, let's teach, let's have the kids do 2 classes at a time during the spring semester, and we're going to teach the entire semester in 4 weeks. So I got to see these kids for 3 hours a day for 4 weeks, but I couldn't teach a whole semester of calculus in 4 weeks. And then once I saw them in January, then that was it. Then I saw my next section in February, and that name sounds familiar, but unfortunately, I never got to, yeah, and I barely remember her. So anyway, what does she do now? From where? Awesome, good. What major?
she wants to. I think it was human biology.
Okay.
So,
Did she want to like
she wants to go to
medicals? Okay, that's gonna be it's gonna be a good path. It's gonna be a long path, but cool, awesome. Oh yeah, I'm sorry. I got distracted talking to you. Here we go. Yeah.
Because
Yeah,
like,
take your time. There we go.
because I actually never, because it's been a while since I've done this. I've done it since like sixth grade, but now
That's all good. And I see you also get extended time too, so I want to make sure you get that. So do you get 50 or 100%? No, extended time. Do you get because I see you have an accommodation for you have a learning plan. Yeah, do you get extra time for tests? Is that do you know how much time you get or
Then like,
50%?
no,
Yeah, that's what I meant. Okay.
recall.
Okay.
But
Okay. No worries. I just want to make sure I'm aware of that. So yeah, go for it.
how long is the break?
I was still gonna like 5, 6 minutes. So I should finish notes early so you should have some more time afterwards.
Okay.
Yeah, exactly. Yeah.
Ryder, you like them? You like Milan? Yeah. You like Bennett? Parker, how do you? That's hard. You like them? Yeah. You like Milan? Milan. Hey. No, literally. That's such a good nickname. Mulan. 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 Oh, so good. I remember the first year. So like the guy. I remember being scared from the sequels, but I'm not as scared.
Okay, let's get back at it. All right. So let me undo this, and I could do that back. Okay. Share screen. My computer's getting really slow now. Why is that? I don't know. All right. Oh, it's back to recording. Cool. All right. Yeah, let's keep moving the notes. Here we go. Okay, distance. Actually, we're gonna distance. The segment also includes points that are not labeled in the diagram. Add a few points. Yeah, let's just move on. Let's talk about distance. Okay. So make sure we're careful of the symbols, right? So if you see just kind of like a dash in a way, I'm not sure what you call that, but that's right there. That's just line segment. If you see an arrow, that's a ray, and of course it's a line. So just be very mindful about that. So this is a segment, ray, and line. Okay, intersection. Intersections where lines or segments or rays meet. Sometimes it's a point. Other times it could be a segment, array, or a line. So they can intersect a lot of different ways. So for example, AB and CI. So let's draw this correctly. So here's, okay, I'm gonna make this straight here. I'm gonna keep my hand steady. Here's AB. And here is CI. What did it have in common? Correct. So intersection is what's common, right? That's all it ever means. Correct. So it's going to be, in this case, point G. It's a point. Name it. You just write the letter. That's it. Straight up, just write the letter. Yeah, there you go. So pretty simple, right? Okay, what about EF? Line EF. Interesting. Okay. And can I erase this? You guys got this? We're good? Okay. Yeah, if I go too fast, let me know. Line EF, which is this. And segment HF. Okay, let's go a different color here. So let's take a moment here. Line EF goes forever towards E and F, right? They go forever. HF is confined between letters H and F, obviously. There is an overlap. Where's my overlap? HF. So HF itself is the intersection with the EF. It's the same thing, right? So if I'll just like circle it. So that's just going to be segment HF. That's because it's an overlap. It's an overlap. Okay, let's see here. What else we got in the notes? All right, let's do some more. How about this? Give my voice a little break. Why don't you guys just turn to each other, or you can work independently. Try the rest of this page here. So yeah, just we'll take a moment. HAGB, HEFE, and then write a couple statements about the diagram that involve intersections. So, and I'll pause my screen. And we'll compare in just in a moment. That won't matter, guys. The order won't matter for a segment. That's weird. Just lost my internet connection for a moment. Well, that stinks. I wrote all the stuff down that got erased. Give me a sec here. Cool. Yeah, so hopefully you said HG or GH for the first one. It's just gonna be a segment that overlaps between Ray HA and Ray GB, sorry. And you could write it's HG or GH, it doesn't really matter for a segment. Or line doesn't matter either. It's a Ray where it does matter. HG and FE. Oh wait, what am I talking about? Okay, I messed that one up. How did I mess up, guys? It's good. I'm glad I made a mistake. That was not done deliberately. I totally made a human error. What should it be, guys? Yeah, exactly correct. Or you can say EH. Doesn't matter. Yes, HE itself. right? Because that's where it overlaps. But segment, HE, mind you, segment or EH. So essentially what you're doing is you're looking for what's common or overlaps between lines, rays, and segments. That's what you're doing. Okay. All right, let's keep moving. Okay, union. Union is basically when you're looking at the combination of everything from the first and second objects. So sometimes union is a segment, array, or a line. So one good way to think of a union, you could think of a marriage, right? Isn't a marriage a union, right? Like some of your parents might be here, someone not, I don't know, but like someone brings something to a marriage, like maybe someone brought like a house in Atherton, right? Maybe someone brought a house in Lake Tahoe. And then you get married. Guess what? Now it's both your houses. And guess what? Then you buy a house. Or I'll think of another one. I have a friend. He's on a second marriage. He had a kid with his first wife. She had twins with her first husband, and then they had a kid together. So what's the union of their family? The kid they have together and their kids from separate marriages, right? So I know again the family stuff's kind of crazy, but the bottom line is the union is when you look at everything combined, right? What they each brought to themselves uniquely, and what do they share, right? So union is going to be everything, right? So let's look at CD and GI. For CD, and the way we write a union, you put a U. So the U stands for union, just so you know. So if you think about it, let's get a highlighter. Highlighter is kind of good. So CD. And then let's go dark blue, GI. Okay. So what's going to be the union of all this? If you think about it, you have to include the intersection, but also what they each brought individually. So correct. The union is going to be CI. Now GD is an intersection, but the union is going to be that. So when we're asked to write a couple statements about the diagram that involve a union, the union is what each item brings individually and what they have in common. Okay. So that's what a union is. Also, let's look at HA and BA, ray HA and ray BA. So let me erase that. Let's go highlighter again. Ray HA goes on forever, by the way. So what did they have in common? They start at H, right? And did they both go forever towards A? Yeah, totally 100%. So it's ray HA. Oh, but sorry, but it's a union, so you have to say BA. My apologies. I gave the intersection. Right. They definitely have that in common, but you have to include everything. So what they each bring individually and what they have in common. Sorry, I just did what's in common when I said HA. Should have been BA because it's everything, including what they bring individually. Okay. Next up, between. We say that a point is between two other points if there are 3 points, if the 3 points are on the same line. Okay, that's fair. The point that is between does not have to be exactly halfway. So like C, G, D. G is between C and D, obviously. Give a couple of other examples of between this. So I'll just kind of just say it out loud. We don't have to write it down, but like, for example, is H between E and F? in the diagram? Yep. Is A between G and B? Nope. Right. So we're looking at between this. So in geometry, we call this a segment addition postulate. This is going to be a big deal because we're going to be mentioning this often. I like to abbreviate as SAP. I know that's kind of a technology term also, but it's where the Sharks play the SAP Center. But yeah, in geometry, we call it segment addition postulate. For example, CG plus GD, if you think about it, makes up the whole thing, CD, right? That would make sense, right? And CD is equal in length to CG and GD combined together. This only works if one of the points is between the two other 2 points. So let's come with another situation. Could you say AG plus GH equals AH? Can we say that? Yeah, totally. Can I say EH plus FI equals EI?
No.
I threw a curveball. Good, I like that. Because what am I missing? HF, right? I can't say that. But I could replace this F here with an H. And now am I okay? EH plus HI. Do you see the link? Have that link. They have that link. Gotta have that link. We gotta link up with a letter. Something they have in common. Very important. We are going to do something called proofs. It could be kind of messy at times. If you had any older students that did geometry and you mentioned proofs, the eyes are going to bulge out of their head. That's because it involves a lot of writing. It's good. It's a good thing to do, though. We're definitely going to talk about it because I want to make sure you guys are comfortable with proving things. In math in general, you have to prove things regardless. Like if you have an equation you have to solve, that's a proof, right? You have to prove like if x plus 5 equals 10, x equals 5, right? You got to prove it by subtract 5 from both sides, right? It's kind of the same thing here. All right, so let's go through these exercises. Oh, we should get this done pretty fast. This is good. I like this. Yeah. Let me just get started with a couple here, and then I'll have you guys kind of take it away. I'll do maybe 1 and 10, the first and last ones, and then I'll have you guys then do the rest in your table groups or individual, whatever you prefer. Let's go to number 1. Okay. The question mark is associated with HG. HF is 10. GF is 1. How long is HG? 9. Yeah, it's pretty obvious, right? That's 9. Right. So you'll do the other ones in a little bit. Okay, this is how we're baking in algebra into this, right? There's clearly some algebra going on here, right? There's unknowns, some letters. I don't know what X is. I'm going to figure it out. But what can I deduce from this diagram? Just using some logic. What can I say about this? How would I make an equation of all this stuff? What can I add together? Can I add this to this? Can I add this to this? And what do all 3 of these things add up to? So what I'm going to do is this, right? I know you're a little hesitant. It's a little weird. And it's okay if you're a little hesitant. I don't fault you for that. It's been a couple months since you've done math, right? But you could say this for number 10. Wouldn't 3x minus 28 plus 3x minus 30 plus x equals 33? And what kind of problem is this? This is a multi-step linear equation. What's my first step in solving this? What would I do? Add all the x's and add all the numbers, which is negative 58. So I combine like terms. What's my next step? Correct. If you need a calculator, of course, use a calculator. 91. And because I do this for a living, I know it's my head, but it's 13. But yeah, you need a calculator, it's totally fine. And that's a proof, by the way. I proved that x equals 13. How did I prove it? I start off with the notion that, hey, all these have to add up to this. Then I combine like terms using some algebra skills. Then I said, oh, okay, I have to additivate to both sides. We call that, by the way, addition property of equality. I have to additivate to both sides. I divide by 7. That's called the division property of equality. I divide by 7, both sides, to get x by itself. And boom, x equals 13. There you go. So I use segment addition postulate. I use simplification. I use addition property of equality. I use division property of equality. And once we get really kind of deep into this, we will actually, you don't have to write this down, but we'll actually be doing something called statements and reasons. I know you don't do algebra this way. You kind of just do it. But there's a reason why we have you do geometry before algebra 2. We need to get you in the habit of organizing your work. So we will ask you guys, not for algebra, but for geometric stuff. We're gonna say step 1, step 2, step 3, step 4. I proved it, right? And what was my first reason? The segment addition postulate, SAP. What was my second reason? I simplified. What was my third reason? I added, call addition property of equality. I know, don't have to write this down for now. Don't worry about this. We will do this later. Division property of equality. I'm just kind of giving you a taste of what we're gonna do in geometry. You're gonna be doing this a lot. I know, it's still painful, but we have to do it. Because once you do it, then you become more organized in your work. Because myself as an algebra 2 teacher, I see some work that's all over the map. And it's frustrating because then they can't really move forward in pre-calculus or calculus, and it just becomes messy. So we want to put you guys in the right path, right? Like, hey, let's get organized and structured here. But for now, just do the algebra. I don't care. Just do the algebra because that's fine. But ultimately, we were going to want to be mindful of writing all of our steps out. So anyhow, go and try 2 through 9, and then and actually try 11 and 12 as well. See how 11 and 12 go. That should be pretty straightforward, I believe. I'll give you guys maybe 4 or 5 minutes, and then we should move on to the last part of the notes. And I'm going to work it out too. All right. So hopefully you got those answers for 2, 3, 4. I could be wrong too. Let me know. I make mistakes, but 12, 12, 16. Cool. All right. Gets a little bit dicier here because you have to solve for a specific segment. I got KO 6. I got HJ was 5. That makes sense. I got for EC, I got 35. Yeah. Yeah, EC's 35, correct. For I should have done a different color pen. For IK, I got 30. 10 we already did. 9 was a bit of a doozy. I got 14.
Yep.
So remember, BC plus CE is the whole thing, right? BD plus D is also the whole thing. Well, I have BC and CE. Sorry, yeah, I do. C is x plus 26, BC is 3x plus 47. Cool, I got that. I got BD, which is 27 plus x. I got D, which is 10. So those have to equal each other, right? Because BC plus CE is BE. BD plus CE is BE as well. Because C line up, B line up. Cool, we're all good. Awesome. Yeah. So you should get 14 when you work it out. Sorry, 11. Sorry, x is negative 12. Then you plug negative 12 back into whatever to solve for CE. CE is going to be yeah, x plus 26. I should have done negative 12 plus 26, but anyway, I got a little complicated there. Cool. And then lastly, these just line up. AB plus BC is 28. AB plus BC is 22 for number 12. So, okay. Okay. Questions? Now, we're a tab behind schedule because I just peeked at the other room. They're ahead of us. We gotta get moving. Let's get moving here. Okay, let's move on to polygons. This is a little less mappy, more terminology. And Ms. Prone, who's taught geometry, and she was our department chair, she's very adamant that we really need to have better terminology, right? So if someone told you, hey, what is a polygon? It's essentially a shape that has a bunch of sides connected. Each side, each line segment we call a side of the polygon. Each endpoint we call a vertex. I'll give you a good example. What did I just draw? It's a very famous building in Washington, D.C. Our Secretary of Defense, right, right. The Pentagon, right. So notice that's a side. That's a vertex. So it's okay. Don't worry if you don't. I'm not worried about that. But what I am concerned about is that you know that this is a side. You know that's a vertex. Corners are vertices. That's how you say vertex in plural. So vertex is a corner. Side is the segment, right? So make sure we're comfortable with that. Now, convex and concave. Convex. Trying to think of the right way to define this. It's gonna sound weird, but trust me, when I draw a diagram, it'll make sense. So I know it sounds weird. A line segment containing two interior points is fully within the polygon, and then the concave is the opposite not. Let me draw a diagram. This will make sense once I do that. Okay. Again, let me draw a pentagon. What does interior mean when you hear the word interior? Yeah, like the interior of your car, an interior decorator, whatever, right? So if I pick 2 points on the inside, if I connect them, is that segment fully within the polygon? Yeah, it is. Now let me draw one that's concave. And when I do this drawing, I think this will help you remember what concave really means. Okay, it kind of looks like a crown in a way, right? Okay, when I connect those two dots, is that segment fully within the polygon? No. Notice how it caves in. That's why it's called concave. It's caving in. There's like a cavity, right? Think about like when you have a cavity in your tooth, there's like a hollow part in your tooth, right? Or any cavity is like coming in, right? That's what's happening here. It's caving in. And so we don't deal with this. This is crazy. We don't deal with something like that, but we deal with convex, sure. It's good to know the terminology. There's also a physics explanation, like lenses are concave. They kind of like have this curvature to it, convex. That's for 2 or 3 years when you take physics, but yeah. So just that's the difference between convex and concave. So I want to make sure we're cool on that terminology. And to help you remember, concave caves in. Convex does not do that. And we're going to work on convex in this class. We don't do concave. This is just really weird. Naming. This will be fun. Here we go. Triangle. Because tri means 3, right? Like a tri-school or triplex. Quad. Or lateral. Goes 4. Now we know 5 is pentagon. What's 6? Good. Because I said this will be fun. Anyone know what 7 is? Sept. These are Latin roots, by the way. Septagon. Anyone that watches UFC, octagon or a stop sign. You just watch UFC fights. I don't really anymore now. 9. Anyone know what 9 is? Nonagon. 10. Decagon. And I'm kind of embarrassed. I don't know 11 or 12. I think 12 is dodecagon. Honestly, don't worry about that. Let me write better. Do, dec, dodecagon. Wait, dodecagon. Hold on, whoa. Dodeca. And then we just say engon. If it's like 25, say 25 gon. So if it's 25 sides, you call it 25 gon. N being the number of sides. Let me look this up real fast. Dodec. I was right. Dodecagon. 11-sided polygon. Ooh, I didn't know that. Hendecagon. Hen. Like a bird. Chicken. Hendecagon. I did not know that. Okay. That's incredibly trivial. So don't worry about that. Okay. Let's keep moving. Oh geez, I gotta rotate this. Right, here we go. Yeah, this is good. This is on the assessment we had earlier today. Yeah, 100%. An equilateral triangle is a triangle with 3 sides, 3 congruent sides. Congruent means equal, like same measure, same shape. Isosceles has 2. Scalene has no or 0 congruent sides. A right triangle has a right angle. So 90 degrees, right? Obtuse has a 1 obtuse angle. Obtuse being more than 90. And a scalene has all 3 angles are acute. Means all 3 angles are less than 90 degrees. So, by the way, triangle can be right and isosceles. They got both classifications. These classifications for angles, just so you know, these 3 right here, are strictly. Let me kind of see if I can lasso this. All these 3 right here deal with angles. These 3 deal sides. So when all 3 sides are the same, it's equilateral. By the way, it's also equiangular. Does anyone know what each of the angle measures would be? It's equilateral. Well, what exactly? What did it all add up to? Well, they all add to 180. 60 exactly. 60 would be equilateral. Scaling, I mean, you could be scaling on obtuse, or you could be scaling right. You could be scaling in acute. That's possible. Isosceles could be right. Could be obtuse. Could be acute. That's possible. That's possible. The equilateral is never gonna be right. Never gonna be obtuse. Equilaterals are always acute. So these can like mix these classifications, but the 3 in the top left are all classifications based on sides. The 3 in the lower right corner are classifications based on angles, just so you know. And less than 90, right? I mean, less than 90 are cute. I always like remember like like small little kid, like I saw my little 2-year-old. She's cute. She's a little annoying sometimes, but she's cute. So obtuse is like really big. It actually means stubborn. If you want to look at the definition of obtuse, like being very obtuse means stubborn, but greater than 90. It's a stubborn looking triangle. If you want to think of it that way, I don't know. Cool. Question on that? All right. Actually, I think we could blast through this pretty fast, get all this done today, hopefully. Next up. More on polygons. Now we're going to look at quadrilaterals. Let me zoom out a tad. Okay, cool. A general trapezoid is a quadrilateral with 1 pair of opposite sides. Okay, that's a general trapezoid. A right trapezoid is a trapezoid with 1 leg perpendicular to the parallel sides. So let me pause that for a moment. I don't want to rush this because people get trapezoids pretty mixed up sometimes. And trapezoids actually kind of come back in calculus. If you do calculus in 3 or 4 years, it does come back in a different way. But a trapezoid is essentially a funny looking shape like this. It's 4-sided, of course. Has exactly one pair of parallel sides. Exactly one pair, not two, because it would be a rectangle, a parallelogram, or whatever. Exactly one pair. So these two are not going to be parallel. But it so happens sometimes the trapezoid could be set this way, where this side here is perpendicular to that. So we call that right trapezoid. Or it so happens that these two sides that are not parallel, they're the same. So we say it's isosceles. So it's one pair of congruent sides. So trapezoids can be broken down in those 3 ways. A very general trapezoid, not really much to say about that. Just one pair of opposite sides. There we go. Board could have one of the sides forming a right angle with one of the parallel bases, or just the sides are not parallel, but they're equal in length. A kite, we have this on the assessment. A kite is a quadrilateral with 2 pairs of consecutive, congruent, or adjacent. So see this right here? These are adjacent. They're next to each other. Those are the same. So that's okay. These are the same. Right? These are the same. It looks like a kite. You fly a kite instead, right? Whatever. Parallelogram. Parallelogram is called out 2 pairs of opposite sides. Yeah, there's not much more to say about it. It's just a quadrilateral 2 pairs of opposite sides. That are equal. And parallel. Okay, I'm gonna use a lot of symbols here. Obviously, you know what equals means. You know, parallel is like, it's like these 2 lines are kind of like tilted a little bit. Just, you know, sometimes we use this symbol also. That means congruent. So that's equals. I should be using congruent. So congruent, this means congruent. What's the difference? It's kind of stupid to be honest. I think it's kind of dumb, but congruent means like same measure and same shape. Of course they're the same. I mean, of course they're equal. I don't know. It just seems kind of vague to me sometimes, but we use the word congruent quite a bit. Congruent means same shape, you know, same measure. I'm struggling with the handwriting here today. Okay, rectangle. A rectangle is a parallelogram with 4 right angles. So it's a special parallelogram. It's a parallelogram that's special. So you have a parallelogram and then it branches out to a rectangle, or a rhombus has 4 congruent sides. All the sides are the same, like a diamond. A diamond is a great way to think about it. Or it's like a kite in a way, but all 4 sides are the same. Square is the most special. 4 right angles, 4 congruent sides. So a square is a rectangle, not the other way around. A square is a rhombus, not the other way around. A rectangle is not a square. Square is very special, right? 4 right angles, 4 congruent sides. And the way the hierarchy works, kind of like if we think like a totem pole, like you got the parallelograms, you got the rectangle rhombus, and you have a square at the top of the food chain. So you can think of it like that. So that's just terminology. We'll review this over and over again. Actually, I think every day we'll talk about this because we should have this kind of discussion. Cool. Okay, we're doing great. Any questions so far? No, we got about 10 minutes. Okay. So I think we can knock this out. I'm confident we can. I don't feel like I'm doing you guys a disservice. So I don't fail you guys today. All right. I mean, I don't want to fail as a teacher, so that's what I meant by that. Okay, for number 1, we'll kind of just do this kind of round robin. And also this is gonna help me remember names. So okay. Allison, what do you think about number 1? Which one would you go with? Yeah, right. It is a quadrilateral, but we want to be very specific. So I'd say a parallelogram, correct. Okay, and then don't tell me. Is it Kelsey? No, you're Kelsey, right? No. You're our Evelyn. No, you're the one sitting next to Evelyn. Natalie.
Yeah.
Yes, Natalie. Yes, go ahead. Yeah. Yeah, totally. Square. Okay. Evelyn, what do you think about number 3?
Quadrilateral.
We could be a little more specific. There's 4 right angles. Yeah, totally. Rectangle. Yeah. Okay, and then Adam, right? Yeah. What do you think about number 4?
Square.
Totally square. Yep. Okay, and then don't tell me not P why am I forgetting your name? I should have it here. Oh, sorry, Wagner, right? Yeah, sorry, my bad. Okay. Okay. Yeah, kite. Yep. Cool. And then Peter. Not quite, just a trapezoid. Because you need these two to be the same. So the arrows just mean parallel, just so you know. I should have mentioned that. When you see this, these markings means congruent or the same, but when you see the arrows, it means parallel only. Okay. And Jake, what else? 7? Just a trapezoid straight up. Yep. Okay, at the end, number 8. There's a kite. Yeah, good. Awesome. You guys are rocking. Okay, and then Kelsey, go ahead.
Quadrilateral.
Well, actually, so yeah, trapezoid had to be just one pair of parallel sides. We don't know that. All 4 sides are the same though, so we can give you a little more specific. It's like a diamond, right? So when all 4 are the same, if you look at the quadrilateral sheet, it's not a square because we don't have rhombus. Yes, yeah. Now, if all of them were right angles, then I would say a square afterwards. Okay, and then Abella, yeah. What do you think about 10? Yeah, that's the best I could say. That's the best I could do for 10. Correct. Good. So let's recap one more time. I'll recap. 1, we said C. 2, we said C. 3, we said D. 4, we said D. 5, we said A. 6, we said D. 7, we said D again. 8, we said B. 9, we said D as in dog. And 10, we said B as in boy. Okay, now let's classify angles. Classify each triangle. So I'll just kind of do this with you guys. So if all the angles are less, if that's 70, right? Then how much is left for these 2 here? How much do I have left over? Right, so 55 each. It's got to be 55 each. So I would definitely say this is acute. But I also can say isosceles. Why am I going to say isosceles? These sizes. So the acute part's for the angle. The isosceles for the sides. So we had a thing of 2 classifications here. So look at 12. I got a right triangle. Are both sides the same? To have 2 identical sides? Yeah, so it's right on isosceles. Yep. 13, everything's all the same. It's equilateral. If that's 68, I got 112. So it's 56, 56. Very close, number 11. Actually, it's acute and isosceles. Okay, go and try the next 4. Questions on those, 11 through 14? Okay, go and try the next 4. I'll freeze my screen. I'll work this out. What do you guys think? So right for sure, but I don't know if any sides are the same. So I can't, and by the way, you can't be right and equilateral. That makes no sense. But right, I don't know. So I would say right's game for 16, definitely obtuse, and 17 definitely obtuse, and 18 definitely obtuse. But 16 and 17 have identical sides, two identical sides for each 16 and 17. 18, nothing's labeled as a sides. So I'll say obtuse scaling. All right, and then lastly, these here. Kind of go rapid fire, get this done. I would say this is going to be a rhombus. Actually, you know what? Let's save this for tomorrow. Because I'm seeing the diagonals now. I'm gonna confuse you guys. I'm not gonna do this in 3 minutes. That's not fair to you guys. These 15 questions. This will be a good segue into tomorrow. How about that? Let me give you guys a homework. Yeah, don't worry about the last page. That's fine. That'll be a good segue for tomorrow. So homework, I'm gonna post it to schools you also in case you lose it. But the expectation to do this tonight. Shouldn't take too long. Honestly, I think you probably knock out like before your next class or
Thank you.
next 10 minutes. Just enjoy just for the day. Yeah. We're gonna know the assessment tomorrow. Knowledgeable assessment. No need to study for it. We'll just do it. Yeah, and it's 10:58.
Thank you.
Let you guys go a little early. Yeah, I'll see you guys. Yeah. Yes, soon.
Oh.
Yeah, no problem. Of course. Thank you.